Once again, welcome to my channel, viewers. Here we are discussing Euclidean geometry, Euclid elements of geometry. The famous Greek mathematician Euclid derived the idea of point, line, and surface from the concept of solid. It says that a solid is it's an object which occupies space. It has a definite shape and it can be moved from one place to another place. Say for example, this is a solid, perfect example of cuboid, right? Now in Euclid's definition, the boundaries of a solid are surfaces. So the boundaries of this solid object is surfaces. These are vertical surfaces. Then you see the horizontal surface at the top and one at the bottom. And boundaries of these surfaces are line segments. You see, for example, this S1 surface, it has four boundaries, right? These are line segments. That means the line is a common boundary between two surfaces. This vertical surface and horizontal surface. Then their common boundary means this edge, you can call this as a line. Then line ends in points. This line ends in the vertices here, one vertex, this vertex, and this is one more vertex. So line end in points. This is how Euclid defined the idea of point, line, and surface. A point has no part, means it has no dimension. Line has one straight dimension. A surface has two dimensions. Suppose it is length and it is breadth. Surface has two dimensions, and it is a solid object. It has three dimensions. This surface has two dimensions, breadth and length. Then you see the solid has a definite height. It has some height. So a solid has three dimensions. Now, after defining these basic concepts, points, line, and surface, Euclid has defined some propositions, and these propositions are called axioms. Axioms are some scientific statements. They are not to be proved. You have to accept them universally. That means they are accepted as truth universally, and these are true to the field of any field of science. And postulates, he also defines some other statements which are specific to geometry, and these statements are also you cannot prove them. You have to accept them as a true statements. These are specific to geometry. They are called postulates. Now Euclid defines some axioms in his elements of geometry. These are like things which are equal to the same thing are equal to one another. A equal to C, B equal to C, that means A equal to B. These two things are equal to the same thing, so they are equal to one another. Equals be added to equals, the wholes are equal. A equal to B and equals be added with equals. A plus C, B plus C, right? So this, the sum of A plus C is also equal to sum of B plus C, since A and B are equal, and same thing is added to both of them. Similarly, if equals be subtracted from equals, the remainders are also equal. A equal to B, so same thing is subtracted from both equal quantities, so their remainders A minus C and B minus C are equal. Things which coincide with one another are equal to one another. Say for example, two line segments, say AC and AB and CD. Now if you coincide with them and you find that they fully coincide with one another, if you overlap AB and CD and you find that they coincide with one another, that means AB equal to CD. That means AB completely overlap on CD. Right? The whole is greater than the part. Line segment AB. Now you consider a point C on this line segment in between A and B. Now AC is a part of this whole line segment AB. So AC is less than AB, or you can say the whole line segment AB is greater than one of its part, AC. Then also Euclid defined two more axioms like the things which are double of the same things are equal to one another. Things which are double of the same thing are equal to one another. Say for example, A equal to twice of B, and suppose C equal to also twice of B. Now these two things A and C are twice of the same thing, that means A equal to C. Similarly, things which are halves of the same things are also equal. Say for example, x equal to half of A, y equal to half of A. These two things are halves of same thing, A. Therefore, x equal to y. So after defining these common propositions, common notions, which are called axioms, Euclid defined some postulates which are specific to the field of geometry. Right? First postulate is a straight line may be drawn from any one point to any other point. Suppose you are given a point A and another point B. So a straight line can be drawn from A to B. That means in between two given points, you can draw only one straight line passing through them. If you are given two points A and B, that means only one straight line can be drawn through A and B. Second postulate, a terminated line can be produced indefinitely. AB is a line segment. Terminated means they are ending at A and B. Now you can extend this line segment to infinity on both sides, produced indefinitely on both sides by adding point on itself. Third postulate says a circle can be drawn with any center and any radius. Any center with A, you can, with any radius, you can draw a circle. Like, so taking A as center, you can draw any circle and any radius. You can increase the radius and you find another circle taking A as a center. Fourth postulate, it says all right angles are equal to one another. These are examples of right angles irrespective of the length of their sides, arms, right? These are arms. Irrespective of these arms, length of these line segments, right? The all right angles are equal. So even if you take different measures of line segments, right angles will be equal, right? So it doesn't depend on the length of these arms. Fifth postulate, it says given a line L and a point P not on the line, exactly one line can be drawn through P which is parallel to L. This line L is given and there is an external point P which is not on this line. Now it says through P you can draw only one line parallel to L. This line parallel to L means it remains at the same distance from the given line. So perpendicular distances are same anywhere. So through an external point of a line, you can draw a line through that point which is parallel to L. Only one line can be made. This is one line given L, this point external to this line. Now through P you can draw only one line which is parallel to the given line. This is the fifth postulate. Now, after defining these two propositions, axioms and postulates, Euclid then tried to derive some results using these axioms and postulates. They are called theorems. So, what are the theorems? There are some propositions which can be deduced or derived with the help of axioms and postulates. So let us first discuss some postulates here. If A, B, and C are 3 points on a line such that B lies in between A and C, then AB plus BC equal to AC. This line, you see, we are taking 3 points here, A, B, and C. B lies in between A and C. Now you have to prove that AB plus BC, sum of AB and BC equal to AC, right? Now, since only one line can be drawn through A and C, and B lies in between A and C, right? Therefore, AB plus BC coincide with AC. We have earlier discussed in Euclid's postulates. It says that, first postulate, it says that a line can be drawn from a given point to any other point. So, in between A and C, only one line can be drawn through A and C, right? You cannot draw second line in between A and C, and B is in between A and C on the same line. That means this sum AB plus BC coincides with AC. Since B is in between A and C and these 3 points are on the same line, so sum of this length AB and BC, it coincides with AC. Now, as per Euclid's axiom 4, what is Euclid's axiom 4? It says that things which coincide with one another are equal to one another. Now, AB plus BC coincides with AC, so these two things are equal. Therefore, AB plus BC equal to AC, or we can say AC equal to AB plus BC. Things which coincides with one another are equal to one another. This is the Euclid's fourth axiom. So now A, B, and C, they are on the same line, and you find that AB plus BC equal to AC, right? So that means the sum of AB and BC coincides with AC, since they are on the same line. If they were on different lines, say A, B, C, if these three were not on the same line, then you cannot say AB and BC coincide with AC. In this case, AB plus BC not equal to AC, right? They do not coincide with one another because B is on the outside of this line. So the sum of AB and BC cannot be equal to AC. It is only possible only when A, B, and C are on the same line. Then only you can say AB plus BC coincides with AC. It is only possible only when these 3 points are on the same line. Next theorem we will discuss here is an equilateral triangle can be constructed on any line segment. Any line segment you can draw, equilateral triangle can be constructed on any line segment. Suppose you are given this line segment. You are given this line segment. This is AB, suppose. Now you can draw equilateral triangle on AB. So first thing, what will you do? Taking A as center and AB as radius, we can draw a circle. Let us draw an arc. It's a part of a circle. This is Euclid's third postulate. It says a circle can be drawn with any center and any radius. So taking AB as a radius, we can draw a circle. Like this is the arc. Again, taking B as center and AB as radius, you can draw a circle here also. This is the third postulate of Euclid. It says a circle can be drawn with any center and any radius. So equal circles are drawn with center A and B. Now these two circles intersect each other at this point. Let us denote this point as C. Now let us join these two lines, AC and BC. Now you see we are drawing two equal circles with AB as radius, taking A as center, one circle. Say this is part of circle S. So S1 means part of first circle, and this is part of second circle, S2. S1 and S2 intersect each other at C. Now you find that AC equal to AB, right? AB equal to AC, being radii of same circle. Similarly, AB equal to BA equal to BC, or you can say AB equal to BC, radii of same circle. Now again you come back to Euclid's axiom. First axiom, it says things which are equal to the same thing are equal to one another, right? Now you see AB equal to AC and AB equal to BC. That means AC equal to BC. These two propositions, from these two propositions you can derive AB equal to AC equal to BC. Things which are equal to the same thing are equal to one another. AC equal to BC, AC equal to BC, then AC equal to AB. Therefore, all these three parts are equal, right? So we find that therefore triangle ABC is equilateral. Equilateral triangle, right? So equilateral triangle can be drawn on any line segment AB, right? Now let us discuss one more theorem here. Two distinct lines cannot have more than one common point. This is one more theorem we will discuss using Euclid's axioms and postulates. Let lines L and M, they are given two lines. To prove that they have only one common point, means they can intersect only in one point. Two lines can intersect only in one point, not more than one point. We have to prove that. Now let us assume that L and M intersect each other in two distinct points. Suppose P and Q. We are assuming that let's say they are not intersecting in one point, they are intersecting in 2 points. These two lines are intersecting in 2 points, P and Q. That means if they are intersecting in P and Q, the lines L and M pass through two distinct points P and Q. Since they are intersecting in two different points P and Q, that means these two lines L and M are passing through two distinct points P and Q. But as per Euclid's first postulate, again you will come to the first postulate of Euclid's first postulate. It says a straight line may be drawn from any one point to any other point, or it can be read as only one straight line may be drawn between 2 points, right? Only one straight line can be drawn through any 2 given points. Therefore, our assumption was wrong. So what was wrong? Our assumption, we assumed that L and M intersect in 2 distinct points, P and Q. That means 2 lines are passing through P and Q, right? L and M, when we say L and M, when we assume that L and M intersect in 2 distinct points, that means these 2 lines L and M are passing through 2 distinct points P and Q. But as per Euclid's postulates, first postulate, it says that through any 2 given points, only one line can be drawn. So through any 2 distinct points P and Q, only one line can be drawn. So our assumption was wrong. We assume that 2 lines can be drawn through P and Q. But Euclid, it contradicts Euclid's postulate number 1. So our assumption was wrong. That means line L and M cannot intersect in 2 points P and Q. Therefore, P and Q must coincide with one another. That is, they must be the same point. P and Q must be the same point. They cannot be 2 distinct points. If you assume that there are 2 distinct points, that means lines L and M, they are passing through 2 distinct points. Now, Euclid's postulates number 1, it says that through a pair of given points, we can draw only one line passing through them. Now, through given, if we are assuming P and Q are different points, we find that as per our assumption, we are drawing 2 lines L and M passing through P and Q. This contradicts the Euclid's postulates number 1. Euclid's, it is contradicting the first postulate defined by Euclid. So our assumption was wrong. That means the line L and M can intersect only in 1 point, not in 2 points. This is how Euclid tried to prove some theorems using axioms and postulates. We will discuss similar problems in next class again. So thank you for watching this video. Please do not forget to subscribe my channel. In the next class, we will try to discuss some exercise based on Euclid's axioms and postulates again.